SpaceX is developing a groundbreaking concept to capture the Starship Super Heavy booster mid-air, which could revolutionize the entire space industry. How and why is SpaceX pursuing this groundbreaking innovation? Let's attempt to understand why SpaceX is taking this ambitious step and how they are planning to achieve it. Since its inception in 2002, SpaceX has challenged the norms and pushed the boundaries of what we thought possible in the realm of space travel. Elon Musk and SpaceX have always been about more than just rockets and satellites. It's about transforming our understanding of the universe and making humans a multiplanetary species. SpaceX has achieved some remarkable milestones along its journey. One of the crowning achievements of SpaceX is the development of the Starship system. This two-stage to-orbit spacecraft is designed to be fully reusable, which would make it the most cost-effective vehicle ever launched into space. The Starship system plays an integral role in SpaceX's long-term vision of making life multiplanetary, aiming to transport humans to destinations like Mars and even beyond. However, the path towards fully reusable rockets hasn't been straightforward. Traditional rocket recovery methods involve parachutes and water landings, but these have proven to be expensive, logistically challenging, and not fully effective. Rockets often sustain damage during recovery or require extensive refurbishment before they can fly again, limiting the reusability aspect. This led SpaceX to a new approach. They've made significant strides with the vertical landing of their Falcon boosters, but capturing the Super Heavy, the gigantic booster for the Starship, presents a whole new level of challenge. Traditionally, after separation, the booster of a spacecraft will fall back to Earth, usually landing in the ocean where it's then recovered. This is a complex process, often leading to damage and requiring significant refurbishment before the booster can be used again. However, SpaceX's different approach involves using the launch tower arm to literally catch the Super Heavy booster as it descends. The Starship, after deploying its payload in orbit, will return separately, guided for a precision landing back on the launch pad. This audacious plan, if successful, presents significant benefits over traditional recovery methods. Firstly, it enhances the reusability of the Super Heavy booster by avoiding saltwater corrosion and impact damage from water landings, thereby increasing the lifespan of the booster. Secondly, this approach offers substantial cost savings. A mid-air recovery eliminates the need for additional fuel and refurbishment costs associated with ocean recovery. By reducing these costs, SpaceX can significantly lower the overall cost of space travel, bringing us one step closer to making space more accessible to everyone. Lastly, the ability to rapidly turn around the Super Heavy booster for its next mission will be a game changer. By avoiding the extensive refurbishment process, SpaceX can drastically reduce the time between launches. Now, onto the mechanism responsible for the actual capture. The robotic arm on the launch tower. Designed to withstand the enormous weight and momentum of the Super Heavy booster, this arm is a marvel of modern engineering. Its strength, combined with the precision of its control systems, allows it to catch the booster and gently guide it back to the launch pad. To handle the tremendous forces involved in catching the booster, the launch tower arm is engineered to be incredibly robust. Furthermore, it will be equipped with dampening systems to absorb the kinetic energy of the incoming booster, reducing the risk of damage to both the booster and the tower. The docking mechanisms also play a crucial role in ensuring the Super Heavy booster can be rapidly prepared for its next launch. After capture, the booster needs to be safely attached to the launch pad, ready for refueling and relaunch. This process involves a combination of mechanical and automated systems that work together to ensure a safe and efficient docking process. However, this concept is still far from being real, and the engineering team at SpaceX will continue to face numerous hurdles, including ensuring the structural integrity of the Super Heavy booster during the catch and developing a control system precise enough to execute the maneuver. The risks are significant. A slight miscalculation or malfunction could result in a catastrophic failure. But SpaceX has shown time and time again that they are more than capable of tackling these challenges. They pioneered numerous technological breakthroughs in their quest to make space travel more accessible, and capturing the Super Heavy booster is their next bold step. The ongoing tests, trials, and refinements are all part of SpaceX's commitment to pushing the boundaries of what's possible. In line with their mantra, fail fast, learn faster, SpaceX adopts an iterative approach in the development and testing of its technologies. This approach has been integral to the development of the audacious Super Heavy booster capture concept. Test flights and prototypes are at the core of this process. SpaceX began the journey by conducting a series of low-altitude hop tests using prototypes of the Starship and Super Heavy booster. These tests allowed engineers to collect vital data on the vehicle's ability to launch, control its descent, and land. The prototypes used for these tests were incrementally updated versions, each one improving upon its predecessor based on lessons learned from the previous tests. This iterative process allowed the team to continually refine the booster's design and performance, and subsequently, the capture mechanism. Several tests involved soft catches, where the Super Heavy booster was guided to a controlled water landing. This helped SpaceX better understand the booster's descent dynamics and fine-tune their guidance systems. The goal was to gradually refine the process to a point where the booster could be guided accurately back to the launch tower. Throughout these testing and development phases, SpaceX encountered both successes and failures. Not all tests were successful, but each one provided invaluable data. Failures, while challenging, were embraced as learning opportunities to understand what worked and what didn't, and adjust accordingly. For instance, some tests encountered issues with the booster's descent, while others had complications with landing burn timing. Each result provided a wealth of information, leading to design changes and adaptations that pushed the project forward. With the Super Heavy booster being a giant structure moving at high speeds, safety is paramount in all operations related to its capture. One crucial aspect of safety lies in the advanced navigation and control systems used to guide the booster's descent. These systems are designed to control the booster's path with exceptional accuracy, ensuring that it returns precisely to the launch tower. Multiple layers of redundancy are built into these systems to allow for the safe termination of the flight in the event of any anomalies. SpaceX has also developed an abort system that can be activated at any stage of the booster's descent. If the systems detect any irregularities or if the booster strays from its intended path, the abort system can steer it away from populated areas and towards pre-designated safe zones. Despite these safety measures, SpaceX is well aware that not all scenarios can be predicted. Therefore, they have comprehensive contingency plans in place for a wide array of unforeseen circumstances. These range from emergency procedures for personnel to technical protocols to safeguard equipment. Moreover, extensive simulations and test flights are conducted to prepare for different scenarios. Each test offers valuable insights and helps refine safety protocols, enhancing the system's overall reliability. By taking these proactive steps, SpaceX aims to not only make the epic concept of catching the Super Heavy booster a reality, but to ensure that it's achieved with the highest standards of safety and risk mitigation. The procedure begins with the launch of the Starship system, which comprises the Super Heavy booster and the Starship spacecraft. After propelling the Starship on its trajectory, the Super Heavy booster separates and begins its journey back to Earth. Guided by advanced navigation systems, the booster undergoes a series of complex maneuvers to control its descent. This includes a flip maneuver that reorients the booster for re-entry and a series of engine burns to slow the descent. All of this is meticulously calculated to bring the booster right back to its launch site. As the booster nears the launch tower, the tower's robotic arm prepares to catch the booster mid-air. The timing here is critical. The arm must move at the precise moment to match the booster's descent speed and trajectory, and gently arrest its motion. Once secured, the arm guides the booster back to the launch pad, where it's docked and prepared for the next mission. Ground control continuously monitors all systems and flight parameters, coordinating with the crew to execute the capture procedure. The crew, meanwhile, is responsible for executing the required maneuvers and responding to any contingencies, guided by comprehensive protocols. It's important to note that while human oversight is crucial, most of these processes are automated due to the high precision and split-second timing required. The ground control team and the crew serve to ensure that the automated systems function as planned and to intervene in the rare event of an anomaly. By significantly reducing launch costs and turnaround times, SpaceX's approach to booster recovery could make space travel more accessible and frequent. This has profound implications for a range of space-based activities, from scientific research and satellite deployment to space tourism, and even the potential for extraterrestrial colonization. The horizons are vast and exciting. Consider the long-term vision of making humans a multiplanetary species. The cost and logistical challenges of space travel have been the main barriers to this goal. By making launches more economical and sustainable, SpaceX could potentially facilitate the establishment of permanent human settlements on Mars or other celestial bodies. This could ensure the long-term survival of humanity and open up unprecedented opportunities for scientific discovery and research utilization. Further, the technology and operational expertise developed by SpaceX could foster partnerships and collaborative efforts within the space industry. This could range from joint missions and technology sharing agreements to the formation of consortiums aimed at tackling specific space-based challenges. The possibilities may be as boundless as space itself. Beyond that, the success of the Super Heavy booster capture could stimulate investment and interest in the space sector. This could drive technological advancements, fuel job creation, and inspire the next generation of scientists, engineers, and explorers. SpaceX's audacious mission to capture the Super Heavy booster mid-flight underscores a new era of reusability and cost-effectiveness in space exploration. This milestone not only amplifies SpaceX's pioneering status, but also galvanizes the broader space community towards unlimited possibilities. As SpaceX continues its relentless pursuit of innovation, we eagerly await a future where interplanetary travel is no longer a dream, but a reality within our grasp.